sorry, in number 14 here, we have -4 times the square root of 117. Now, in this one here, I want to factorize 100, or I want to find the, look at 117. I'm looking with the number that is under the square root. Now, the two ways I can take the perfect square number, multiply by any other number and continue, or I can find the prime factors. How can we find the prime factors? I will write 117 here, make like a tree here. Now, 117, yesterday we said that I want now to see which are two numbers that if I multiply them, I get 117. Any two numbers. How can I know? I will add these three numbers here. 7 plus 1, 8 plus 1, 9.
9.
Now, since 9 is a multiple of 3, so I can divide it by 3. Is it right?
Yes.
Yes.
Okay. Then after that, let's divide here 117 by 3. 11 over 3. 3. 3 times 3, 9. 11 minus a 9, 2. Then I will add 7.
It's going to be 39.
Divide by 9 by 3.
9.
9.
So I will say it now. It is 3 times 39. Then I will factorize 39 because 39 is not a prime number. 3 is a prime. I will stop. I will go now to the composite number. To the composite number here, I want now also to factorize it. Now give me two numbers. If you multiply them, you get 39.
3 and 13.
Excellent. 3 and 13. How? You can say 9 plus 3 is 12. And since 12 is a multiple of 3, so I will say it can divide by 3, and then I will divide 39 by 3. You will find that is 30. Then after that, I will come back here. I will say -4, keep it as it is. Then square root of. Let's take the three numbers. What are these three numbers? 3, 3, and 13. The prime factors. Let's say now, here we have 3 times 3. We write them as 3 squared times 9. If you have two numbers repeated, write them as 3 squared. Okay? It's clear?
Yes, teacher.
Okay. Then after that, I will distribute the square root as we said yesterday. Square root here and another square root here. Then I will write the 3 squared here and sorry, not the 9, the 11 here. By mistake, I write it. Here we have 13. I will write it here and here also. Then I will say, as I told you in chapter 7, the square root cancel the exponent 2. Yeah, I mean the square cancel the square root. So I have only, after they cancel them, I have 3 only. 3 square root of 13. I keep it as it is. Then I multiply it by -4. So the final answer is 3 times -4.
-12.
-12
-12.
of 13. Is it clear now?
Yes.
Yes, teacher.
Yes, teacher.
Which one you find it easier, the perfect square or this way?
No, the perfect square.
The perfect square.
The perfect square.
Okay. Let's do now number 15. Do you have any question here for number 14?
No.
No.
And for the perfect square, how
No.
can you solve it? For the perfect square way, what did we have to do? We can, as we said yesterday, we have 1, 4, 9, 16, what's also 25, 36, and so on. So what we have to do here in number 14 is say that I will look at any of these number any of these square number. If I multiply them by another number, I will get 117. So how can I know? I can try, or here, since 117 is if you add the numbers 7 plus 1 plus 1, and you say it is a 9, since 9 is a multiple of 3, so it can divide by 3, so it can divide also by 9. So 117, it can be divided by 9. Then I will ask myself, let's divide 117 by 9. We say 11 over 9 is 1, 1 times 9 is 9, so we have 2, 72 over 9 is 3, so it is
13.
9 times 13. Then I will continue. Let's do now number 15. In number 15 here, we have 5 square root of 700. So now I will ask myself, what is the greatest perfect square factor that if I multiply it by any another number, I get 700. I want the greatest perfect square number. Let's see now, or let's write the perfect square number here. 25, 36, 49, 64,
107
100. 100
and 7.
Is it right?
Yes.
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 If you multiply 100 by 7, you get 700. Then after that, I will now distribute it into the 2 square root. Here we have 100 and here we have 7. Then I will continue now. 5. What is the square root of 100?
10.
10.
10.
Times square root of 7. So the final answer here will be 5 times 10
50.
50
50.
square root of 7.
7.
So now some of you teacher type, I can say that 25 multiplied by 28, I will also get 700, and 25 is a perfect square number. But that's why I told you, give me the greatest perfect square number. I want the greatest one. Okay?
Okay.
Yeah. Do you have any question here now?
No. Perfect square number means if I took a small number, I need to simplify more and more.
Yes, exactly.
Okay.
If you solve it by another number like 25 times 28, you'll say it is okay, this is a 5. But this 28, it can be factorized by 7 times 4. Then you will say the square root of 25 times the square root of 4 times 7. 5 times 2 is 10 times square root of 7. Now, sometimes we can simplify radical expressions that contain variables. A variable with an even exponent is a perfect square. If you have a variable like n squared, this is a perfect square, or n to the power 4, or n to the power 6, or n to the power 8. Any variable with a even that is raised to an even number is a perfect square variable. Okay, any variable raised to any even number is a perfect square variable. Clear? Is it clear?
Yes.
Okay, but if there's a variable that is raised to an odd exponent, like this variable that is raised to a odd exponent is a product of a is a variable of perfect square, or is a product of a variable perfect square times any the third and times variable. Like what? Look at any cubic here. I told you that these are n raised to an even number. This is not a perfect square. What I have to do, I will write it as a product of. Now give me the closest number to 3. That is, or give me the closest even number to 3. Small
2 and 4.
2.
2.
But I want the small one. So I will take 2.
2.
So since 3 is 2 plus 1, 2 plus 1 is 3. So I will write it them as, I will distribute n like this. Since that n multiply n times n squared, I can add the exponents to be as n cubic. So I can write it as n squared times n. N to the power 5. It is n squared times n squared times what?
1.
N times
N.
n. 1.
Exactly. Why?
N.
Look here, I have number 5. So I say 2. I know that 5 is 2 plus 2 plus 1. Now, n to the power 7 is n squared times n squared times n squared. Is it right? 2 plus 2
Yes.
plus 2 is 6.
Yes.
Plus n, 7. N to the power 9. It can be written as n squared times n squared times n squared times n squared. So we have 8 times n to the power 1. Or you can write it as n to the power 8 times n. I want you now to know this way. Is it clear? How can we represent a variable with an odd exponent?
Yes.
Okay.
Yes.
So by now we know how can we simplify, or how can we present an odd exponent, and how can we represent a not perfect square number. Let's see now here how can Here now we want to simplify a product of a number times a variable. A number times a variable, like square root of 54 and to the power 7. Now, the first step, I will put them in two parts. One is square root of 54 and the other one is square root of n to the power 7. I will put the 54 under a square root and n to the power 7 under another square root. Then I will come now to the constant, to the number. Come to the number 54 here. I want now to ask myself, what is the greatest perfect square number that if I multiply it by any other number, I get 54?
9 multiplied 6.
9 multiply 6. Yes, but it is not the greatest one because 6 is not a prime number.
Okay.
Teacher, 16 times by 4.
No, 16 times 4, 64.
Mm.
Yalla, think about it quickly.
17, teacher, times.
So let's see now who says 9 times 6.
Me, teacher. Me.
So you can say 9 times, think about 9 times 6 in other words. Let's say type, okay, it is 9 and 6. Let's factorize 9 and 6 to 3 times 3. Okay, I'll keep it now. And here we have 3 times 2. So now you can say, oh, okay. So we said 9 times 6. I think 27 times 2. Is that right? 27.
Yes, teacher, it can be
Yes,
27 times
2,
2.
but 27 is not a perfect square. So I look at 9 times 6. I'm sorry, I think I was thinking that it is another thing. So let's take it as 9 times 6. Yes. This is true. Yes, yes. I'm sorry, no, I told you no. It's true. So 9 times 6. Then after that, let's factorize 9 and sorry, let's distribute now the perfect square number into 9, the square root into 9 and 6. Then what is the square root of 9?
3.
It's 3. And square root of 6?
Square root of 6.
Yes, it is square root of 6. Okay, so I will stop here. This is for only for 54. Now let's go to the variable. N to the power 7. What you have to do? I will now factorize it as n squared times n squared. Shall I stop? If you add them, did I get 7?
No.
No. Times what?
N
squared.
Times n squared times
N.
n. Exactly. Then after that, let's now distribute a square root into these two variables. How many variables here we have?
4.
3.
4. 4. So I will write 4 square root.
Teacher, we also count the n.
Yes, yes. So I will write n squared here, n squared here, the third n squared here, and n here. And then after that, I will now cancel, since the square root cancel the square exponents. So I can say this one cancel this one. So I have only n. Square cancel the square root. So I have only n. Square cancel the square root. So I have only n. But here there's no square exponents. So I keep it as square root of n. Is it clear?
Yes.
Yes, teacher.
Then after
So
that,
teacher,
let's simplify it now. Wait, please, but after I continue. Let's now simplify it. I will write here. I will gather here the numbers without the square root first. Then I will write the numbers with the square root. What are the number and the variable without the square root?
N to the power of 3.
3
and n. And
and
what?
n.
And n.
So I will say 3. And since we have n times n times n, so I write them as
N
n
3.
cubic.
N to the power of 3.
Yes, n cubic or n to the power 3. Then after that, let's now look at the square numbers or the numbers under the square root. What are these numbers?
6
and n.
n.
6n.
Square root of 6 times square root of n. I will gather them. I will combine them in one square root. How? I will put a one square root, then I will multiply
6 times n.
Okay, I will combine them like this here. If I have square root of 4 times square root of n, I will write one square root, then I will write here 4n. Because before that, if we have 4m, I told you we can distribute it into two things, or two square roots. And also the two square roots, I can combine them in one square root. So it will be 6 times n, which is 6n. So this will be now the simplified one.
Teacher,
Yes.
for this square root of 4, it's just an example because I will not write it as it in the square root multiplied by n.
Sorry?
Teacher, if
This is the
square root-
example. Yes, yes.
okay.
But in how to tell you how can we combine two numbers, or one number and variable, how can we combine them in one square root?
Okay.
Is it clear?
Yes,
Yes, teacher.
I will solve many examples now. Yeah, look at this one here. Negative m One minute, please. I will come back. So negative m square root of 80 m to the power 9. I'm sorry, but my son repeating after me. So here we have negative m square root of 80m to the power 9. Here we have negative m, keep it as it is. I don't want to simplify it. I will simplify. So here I have to simplify now 80m to the power 9. I will write now 2 square root. 80, one is for 80, and one for m to the power 9. Then after that, let's now work with 80. Now give me a greatest perfect square that if you multiply it by any other number, you get 80.
So can you use 8 multiply 10?
But 8 is not a perfect square and 10 is not a perfect square.
40 and 2.
Sure. 40.
40 is not a perfect square also.
4 and 20.
4 and 20, thank you. No, sorry. Yeah, but 20 is it's not a greatest one, because the 20 here you can factorize it also into 4 and 5.
40 and 2.
No, 40 is not a perfect square. Type. Look here. Let's have 20 and 4. Okay, we said that it is 80, 20 and 4. Then after that, I want you know now to factorize 20. It is 4 and 5, is it right?
Yes.
So
Yes.
I can write it as 4 squared, which is 16, times 5. Okay? If you think that 20 times 4, you can say it is 4 times 4, which is 16, times 5. How, if you multiply these two numbers, you get 80. Is it clear?
Yes.
I want
yes.
to give
Yes,
you
ma'am.
ways how to think. If you have a 20 times 4, how can you make it as a perfect square times a prime number?
Okay, miss. Yes.
Then, after that, let's now distribute. Oh, Alena. Let's now distribute the two numbers here. One is 16 here, and 5 is here. What is the square root of 16?
4.
4.
4.
4.
Square root of 5 and negative m. Keep them now like this. Now let's come to the variable. Here, what did we have? We have m to the power 9. We can write it as m squared times m squared. Shall I stop?
No.
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 Times m squared times m squared times m.
I will say 2 plus 2 plus 2 plus 2 is 8, plus 1 is 9. Since that, if you add the exponents, oh Allah. Since now we can add the exponents, so I can get 9. 2 and 2 and 2 and 2 and 1. If you add them, you get 9. Then let's now distribute them. Since we have 1, 2, 3, 4, 5 variables, so I have to write 5 square roots. Then after that, square cancel that m, square cancel the square root, m, square cancel the square root, m, square cancel the square root, m, and here there's nothing, so keep it as square root of m. Then after that, I will try now to combine the numbers and the variables without a square root first. Then I will combine the numbers with the square root. Is it right?
Yes.
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 Let's continue here now. I will look at this the white one here. Let's write, oh, let's continue up. Now, what are the variable and the numbers without a square root?
Negative m and 4. And m and m and m and m.
Yes,
Yes, like
we
this.
have m, and m. So we have 5 m's. So we keep it as negative 5. Oh, sorry, we keep it as m to the power 5. Then, since we have a negative sign, write it here also. So I have negative m to the power 5. Then I will write the square root. What are the two numbers or the two variables or the number with variable under the square root? Here we have
What
also
about
4. I forget 4. This 4. Write it here also. Negative 4m to the power 5 times 5m.